We now discuss the solution of a problem from the section complex numbers, and the problem is also on the complex numbers. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is, let S be the set consisting of Z belongs to the set of complex numbers such that modulus of Z minus 3 less than or equal to 1 and Z multiplied by 4 plus 3i plus Z bar multiplied by 4 minus 3i less than or equal to 24. If alpha plus I beta is the point in S which is closest to 4i, then 25 times alpha plus beta is equal to. So we are given a set S consisting of Z belongs to the set of complex numbers satisfying these two conditions. And in that region S, alpha plus I beta is the point which is closest to 4i. Then we have to find 25 times alpha plus beta. We now discuss the solution of the problem in detail. We have S is that given set. Now S is written as S is equal to S1 intersection S2, where S1 is the set of all those complex numbers Z such that modulus of Z minus 3 less than or equal to 1. And the second set S2 is the set of all those Z belongs to C such that Z multiplied by 4 plus 3i plus Z bar multiplied by 4 minus 3i less than or equal to 24. Now, what is S1? S1 is this set. In this, put Z is equal to x plus iy. Then you will get modulus of Z minus 3 as x minus 3 plus iy modulus less than or equal to 1. And that will be under the square root of x minus 3 whole square plus y square. That is same as x minus 3 whole square plus y square less than or equal to 1. So put z is equal to x plus iy in that. Then the set consisting of all ordered pairs x comma y belongs to R square such that mod of x minus 3 plus iy less than or equal to 1. And when you take the modulus square, this is still less than or equal to 1, and that will be x minus 3 whole square plus y square less than or equal to 1. So what is this S1? S1 is a circle with the center C at 3, 0 and radius 1. S1 consists of all points that lie inside. Why? Because less than 1. On, because it is equal to. So S1 consisting of all points that lie inside and on this circle with the center C at 3, 0 and radius 1. So this is the figure. This is the diagram. So x-axis. So real axis, imaginary axis, the circle with the center C, radius 1, and all points that lie inside and on this circle. So that is S1. Let's look at S2. We have S2 is the set of all Z belongs to the set of complex numbers Z multiplied by 4 plus 3i plus Z bar multiplied by 4 minus 3i less than or equal to 24. So this is same as Z belongs to C, set of all Z belongs to C such that, and 4z, 4z bar, 4 is taken common, z plus z bar and 3iz minus 3iz bar, 3i is taken common, multiplied by z minus z bar less than or equal to 24. And we have z is equal to x plus iy. Z bar is its complex conjugate, that will be equal to x minus iy. Add these two things, 2 z and z bar, we will get z plus z bar is equal to 2 times x. And subtract, you will get z minus z bar is equal to 2iy. So for z plus z bar, put 2x, and z minus z bar, substitute 2iy in this. So then you will get the set of all x comma y belongs to R square, such that 4 into 2x plus 3i into 2iy less than or equal to 24. And this is now 2 is common throughout. 2 cancel here, 2 cancel here, 2 12s are. So this will be set of all ordered pairs x comma y belongs to R square, such that 4x minus 3y less than or equal to 12. Now in this, 4x minus 3y is equal to 12 is a straight line. And what is that straight line? X by 3 minus y by 4 is equal to 1. That is a straight line. And it is less than 1 also is there. So x comma y, this is the set of all ordered pairs x comma y belongs to R square. X by 3 minus y by 4 is less than or equal to 1. Now notice that x by 3 minus y by 4 is equal to 1 is a straight line, passes through the center 3 comma 0 of the circle. So substitute 3 comma 0 in this. Sorry, x is equal to 3, y is equal to 4. So this equation is satisfied. Therefore, this line x by 3 minus y by 4 is equal to 1 passes through the center of our circle C. Center C 3 comma 0 of the circle. And now what is this region? That is x by 3 minus y by 4 less than or equal to 1. What is this region? Is it above this line or below this line? That is the question. So what we have taken is 3 comma 0 is the center of the circle, and take a point, no, take 2 comma 0 on the same real axis, 2 comma 0 take on the left hand side. So now substitute in this, x is equal to 2, y is equal to 0, 2 by 3 is less than 1, less than 1. So further, the point 2 comma 0 satisfies x by 3 minus y by 4 less than or equal to 1, this inequality. Therefore 2 comma, and you know 2 comma 0 lies to the left of x by 3 minus y by 4 is equal to 1, and it lies above this line, So therefore S2 consists of all points that lie above and on this line, above and on this line. So it's like this, so this is the straight line. This is the straight line. X by 3 minus y by 4 is equal to 1 is the straight line, and 2 comma 0 lies here, and that satisfies that inequality. Therefore, and the region decided by this inequality is the region in which 2 comma 0 lies, that is this portion, that is above the line or to the left of this line, above the line. So S2 consists of all points that lie above means this way, and on this line. Agreed. And what is our S? S is S1 intersection S2. So S1 is that circle inside and on, and S2 is the region above and on this line, and the common portion S1 intersection S2 is the region shaded in both the colors, both in blue and uh, light red. So that is the S is the region. So S is shown here. So now we continue in the next slide. Let A be the point 4i. 4i is 0 comma 4 on the imaginary axis. Agreed. This is your imaginary axis. A is 0, 4. Agreed. Now, given that alpha plus I beta is the point P in S closest to 4i, closest to A. So, then what will be that point? Then P will be the point on the line joining A 0, 4 to the center C 3, 0 and lies on the circle. So, P is the point on the line joining A 0, 4 and C 3, 0 of the circle, center C of the circle, which lies on the circle here. So, which lies on the circle. So, this is the P alpha, beta. So, the minimum distance, because 4i is closest, therefore the minimum distance is AP. The minimum distance is AP, that is measured as the distance A to C. A to C is the distance between 3, 0 to 0, 4, that is under the square root of 3 square plus 4 square minus CP. CP is the radius of the circle, that is 1. So that is under the square root of 3 square plus 4 square minus 1, and that is 5 minus 1, that is 4. So this is AP is 4. Obviously PC is 1. PC is 1. And thus P alpha, beta is the point which divides the line AC, A with 0, 4, C with 3, 0 in the ratio 4 is to 1 internally. 4 is to 1 internally. We have this formula, the section formula. The section formula is here. Here we apply that and we'll write alpha, beta is equal to 4 times 3 plus 1 times 0 by 4 plus 1, and 4 times 0 plus 1 times 4 by 4 plus 1, and that is the internally this alpha, beta is dividing this line joining AC with a 0, 4, C 3, 0 in the ratio 4 is to 1 internally. We use the section formula, and that will be equal to 12 by 5, 4 by 5. These are the two ordered pairs equal. Two ordered pairs are equal if and only if the first component is equal to first component and the second component is equal to second component. This will imply alpha is equal to 12 by 5, beta is equal to 4 by 5. What is that we require? We require 25 times alpha plus beta. So 25 times alpha 12 by 5 plus beta 4 by 5. When added it is 16 by 5, and 25 into 16 by 5, 5 5s are 25, 5 into 60, that is 16, 5 into 16 is 80. That's our answer. So that is the question. Uh, Definitely an interesting question, and this is from the section complex numbers, and concentrate on the section complex numbers for more problems of this type. I'm sure that you have understood the solution of this problem. I wish you all the best. Thank you.